Right, standard 8.5b is talking about figuring out where a number falls after we take the square root of it. In between which two consecutive numbers does a square root fall? Or it could be asking backwards of that, in between which two perfect squares does the original number fall? That's exactly what these two things are asking about. In between which two consecutive numbers does the square root fall? Or in between which two consecutive perfect squares does the original number fall? So we're going to go through both of those types of examples. That is the entire standard, though. That's everything we need to know for this entire standard. All right, so there's two ways we can handle this. We can actually just do what this is saying. Do the square root of 32. Square root of 32 would give us 5.66. What two numbers, two consecutive numbers, two numbers in a row is that in between? Consecutive just means two in a row. 3 and 4, 4 and 5, 5 and 6. And actually that's the pair that we want to use. It's right in between 5 and 6. It's a little bit bigger than 5, a little bit smaller than 6. We could do it that way, or if you're like me and you're lazy and you don't even want to pull the calculator out, you can look at what that is in between. What two perfect squares that's in between. And that's actually exactly what this is talking about. It's in between 5 squared and 6 squared, which is 25 and 36. It's directly in between those two. Those are the perfect squares that's in between. Okay, so honestly, if I was doing number 1, I would think about the number 2 first. I would think that this is in between 25 and 36, so I know that the square root of that is in between the square root of this and the square root of this, or 5 and 6. Alright, you see how all we're really doing is adding a square root symbol to go from this example to that example. Let's clean this up. On the second example, actually I'm going to do all of these pairs together. Alright, so on each of these, I'm going to do example 2 first, because that's really just the way I think about it. I think about what perfect squares is that going to be in between, and I know when I take the square root of those two numbers, that's going to tell me these two numbers. If you want to do it the other way, if you want to just take the square root of 132 and find out what decimal that is and what numbers that's in between, that's fine too. And you can even work backwards from that. Then you could square those numbers and bring them over here. You could work this either way, backwards and forwards. I'm going to start with example 2 though. So I see the number 132. I know that's in between perfect square of 121 and 144. Again, if you don't see those numbers right away, you could do the square root of 132. That gives you 11.4 something, doesn't really matter. It's in between 11 and 12. And the way I would have done that is I would have taken the square root of 144 and gotten 12, and taken the square root of 121 and gotten 11. And I know that this has to fall in between those two because the original number lands in between those two perfect squares. Again, if you don't see that right away, you don't have to use that. Alright, so on the next example, 12 is in between 9 and 16. Those are my perfect squares. I'm going to take the square root of each of those. Square root of 9 is 3. Square root of 16, square root of 16 is 4. I'm just going to confirm it just to make sure. Square root of 12 is 3.46. That makes perfect sense because it's bigger than 3, smaller than 4. It's right in between those two. Alright, so 82, that's just above 81. That's 9 squared. And it's smaller than 100, which is our next one. That's got to be 10 squared. 9, 10 are the consecutive numbers. 81 and 100 are the consecutive perfect squares. We are in the exact same number range here. This is just less than 100, and it's got to be bigger than 81. So we're going to use the exact same two numbers, 9 and 10. 2 is in between 1 and 4 for the perfect squares. Again, we could just do the square root of that and get 1.41. That's in between 1 and 2. This is weird because that number stayed exactly the same, but really that's the square root of 1, and that's the square root of 4. Alright, on number 3, now we're going to actually plot these on a number line. This is really asking us the same thing. What two numbers does this fall in between? Alright, so we're going to just take the square root of each of these and figure out what those are as decimals first. I'm going to do all 5 of them. 7.93, really 4 when we round it up. Square root of 81 is just 9. Square root of 70 is 8.37. Square root of 3 is 1.73. And the square root of 50, it's got to be just above 7, 7.07. Alright, so now we're going to try to plot each of those. I'm going to pick out the easy one first. I'm going to put 9 down first. I'm going to use the letters just to make it easier. B is directly on top of 9. Alright, I'm just going to go least to greatest here. I see I have 1.73 next. 1.73 is somewhere in between 1 and 2. The halfway point would be 1.5. I know it's past that, so I'm going to put a little bit past that. That's D. The next one's going to be 7.07. That's just past 7. That is just bigger than 7. That's E. A is also just past 7, but that's really closer to 8. 7.9 is pretty close to 8. That's actually on this side of it. Should even be closer to 8 than that. And that's our A. And then C has to be our biggest one. That's in between 8 and 9. It's about halfway in between 8 and 9.